Hi, my name is Alejandro Orozco and today we will talk about Toyotismo. My teammates are José Antonio, Carla Guadalupe, Daniel Lisette, and Stephanie. Introduction. In this project we will discuss the issue of Toyotism, which we consider to be a pillar within the industry because it has been of great importance to be able to improve in the production of cars and manufacture items. Since I show the right way to produce based on a continuous flow of the product so that I can meet the needs of customers. History of Toyotism. The Toyota production system emerged out of necessity in response to the circumstances surrounding the company. The oldest part of the production system is the Jidoka concept, which was created in 1902 by Toyota's founder, Sakichi Toyota. This concept refers to the notion of quality construction in the production process, as well as allowing the separation of people and machines for the manipulation of multiple processes. Sakichi invented a loom that stopped automatically when it detected that a thread was broken. This stopped the faulty material creation process. TPS objective: provide products with world-class quality labels to meet customer expectations and be a model of corporate responsibility within the industry and the surrounding community. Vision and philosophy. Since Toyota's foundation, we have acted in accordance with our guiding principles to produce reliable vehicles and the sustainable development of society through ever-changing innovation and the provision of high-quality products and services. Guiding principles at Toyota. Honor the language and spirit of the law of every country and region, and undertake open and fair business activities to be a strong corporate citizen of the world. Respect the culture and customs of every country and region, and contribute to economic and social development through corporate activities in their respective communities. Dedicate our business to providing clean and safe products and enhancing the quality of life everywhere through all our activities. Create and develop advanced technologies and provide outstanding products and services that fulfill the needs of customers worldwide. Foster a corporate culture that enhances both individual creative and the value of teamwork, while honoring mutual trust and respect between labor and management. Pursue growth through harmony with the global community by innovation management. Work with business partners in research and manufacturing to achieve stable, long-term growth and mutual benefits while remaining open to new partnerships. 5 main principles of founder Sakichi Toyota. Always be faithful to your duties, thereby contributing to the company and to the overall good. Always be studious and creative, striving to stay ahead of the times. Always be practical and avoid frivolousness. Always strive to build a home-like atmosphere at work that is warm and friendly. Always have respect for spirit matters and remember to be grateful all at times.
What is it? What is it? The Toyota Motor Corporation's vehicle production system is a way to produce things often referred to as the adjust manufacturing system or just-in-time system (JIT), which has become well known and studied around the world. The next. The Toyota Production System (TPS) was established on the basics of two concepts: Jidoka, which can be translated as automation with a human touch, since when an error arises, the equipment stops immediately, preventing defective products from occurring. And the second concept is just in time, which is that we think each process only what is necessary for the next process in a continuous flow should be produced. The next. The TPS concept, and the TPS concept for Toyota, Jidoka means a machine must stop safely every time an anomaly occurs. Therefore, achieving Jidoka requires building and improving systems behind on time. They are reliable and safe. The next, please. And the next, please. In this part, the house of TPS, we found that a common way to represent the TPS Toyota production system is through a house, and how every house should be built from its foundations. Um, we need a settled and stable foundation in the organization, since as already indicated in a previous post, to be able to apply lean management in an organization, it is necessary to understand that is a long-term philosophy that has to link all members of the organizations. The next, please. The next, the house of TPS. Um, the TPS Toyota production system is explained using a house, because a house represents a structure that is strong as long as the foundations, as the column are strong. By the time either party is unhealthy, it will weaken the rest of the system. We can say that lean house or TPS house consists on four elements. Um, First element is foundations, second element is heart, third element is pillars, and fourth element is roof. The next, please. The first the first the first element is the foundations, and they are based on the implementation of a culture, a lean philosophy. This philosophy is the one that will give stability to the house. All members of the company must have the right information and have standardized and reliable process and operations. The next, please. And second element is the heart. The heart, it is continuous improvement to do these teams and people work I made to obtain reducing cost and inefficiency. Uh, the next. Uh, the third element is the pillars. In the pillars, we have the lean tools. We can represent them by the tools just in time to manufacture only what we need in the quantity we need and when we need it. And second is Jidoka, use techniques to detect and correct production defects using the necessary procedures and mechanisms that warn us of anomalies. And the next, please. And fourth element is the roof. The roof here is represent everything we see: quality, cost, deadlines. It represents the results of the solidity of the rest of the house, the lowest lead time, the best quality, and the lowest cost are sought. And a common mistake in many organizations is to implement a Kanban tools, GIT, and 5S. It represents no, only to the manufacturing plant or workshop when they are tools designated to be implemented and applied through the company. If in addition to making the above mistake, the organization is not able to understand that the TPS or lean management model goes beyond applying a number of tools, and that is should be complement as we are continually repeat as a long-term project established philosophy and company culture based on the principles of the Toyota system. We can explain why many companies are not able successful implement Toyota.
Hello, my name is Carla Gonzalez, and today I will talk about the focus areas of Toyota Production System. Here we have that the TPS includes all activities that, of course, add value to the product. In this case, the driving force of the Toyota Production System is the elimination of waste, aimed at ever improvement quality, cost, productivity, safety, and model. We have to, well, in promoting the Toyota production system and the concept of continuous improvement, we have to keep in mind the concept complete elimination of waste. Here we have that waste is all about factors that do not add value to the product or to the service, if we have the case. It could be parts, labor, or production process. Eliminating waste. It requires constant efforts at cost reductions to maintain continuous profits in manufacturing. Well, we have here seven forms of waste, or seven of the seven major types of waste. And I will talk about each of one in the next slides, but I would like to tell you all of them. And it's about correction, overproduction, waiting, conveyance, processing, inventory, and motion as well. Well, the first one is correction. And here we have that the waste of correction is a result of poor internal quality. When we have to correct something in production, or well, products requiring repairs, this at cost of extra manpower, materials, facilities, and transport measures. Well, here have some examples of correction. And the first one is the waste of extra handling, the waste of additional labor, also the risk of other defects caused by additional handling, and the risk giving of our customer an inferior product. The second one is overproduction. Here in the Toyota production system pays particular attention to the waste of overproduction. We have two different types of overproduction. The first one is production too much, and the second one is producing too early. Both of them are bad. In this case, the production too much, this overproduction invites more waste because it has problems behind the avail of inventory. We have here some examples of the waste caused by overproduction. Here, well, I believe that the one of the most important is that this increase in storage and warehouse space. If we have overproduction, we don't and we don't have the space to hide the product, it will be a very huge problem. We have here factors that cause overproduction, and it could be like variations of in load or the notions that line stoppage are sinful, also the sense of security against machine, breakdowns, defects, and absenteeism. Well, here we have that to avoid overproductions by balancing, we have to balance the supply and the demand. If we are not able to supply the demand, we have to be very careful with the production. The third one is waiting. And here we have, well, we have to be very careful with the time. As we all know, is a limited resource. In the manufacturing world, time is money. So customer requirements are calculated to the second, many waiting due to the breakdowns, changeovers, delays, poor layout as well, or work sequencing. These need to be eliminated through preventive maintenance. So if we are careful with all these factors, we will have a good time. And as you know, we have to take care because it's a limited resource. Conveyance. This is a difficult word if you want to see like that. So we have to change to transport. So in transport, inefficient layouts are facility design results in transport files. So um, we have to be a good engineers, if you want to see it like that, with the layouts and well, here materials should process from one cell or position to the next as quickly as possible, but only if we have a good design of the layout. The second one, well, the next one is processing, and we have here uh, this is very similar to overproduction, but this is processing. And overprocessing is a wasteful as inefficient processing. Well, if, for example, if a team member is wasting time and energy, if he or she streams or flash from a Class C area of a PVC window when, well, it's unacceptable. So we have, well, employees must learn to identify overprocessing, waste, and perform the appropriate amount of processing of parts without spending more time or effort than that it is necessary. The next one is inventory, and I mean that this is very important because preventing unnecessary inventory is critical to the success of the Toyota production system. As we talked before, we have to balance the supply to the demand. So we have to be very careful with the inventory. And yeah, and work in process develops because of equal capabilities within the process. So we need to put more effort to balance all the inventory to, yeah, balance. And the last one is motion. Motion here is very important because this motion occupies time and energy. And well, ideally, all unnecessary movements or action are eliminated from the work process. But we are not robots; we are humans. So we, as humans, we need to pay attention in the process that we are doing. And here, well, the same improvement that eliminating waste motion. often have ergonomic benefits as well. Well, as we talked before, we already know that the aim of the Toyota production system is to ensure that all activities adds value to the product. It is irresponsible to allow non-value adding work to continue. So here we have the difference between value add and non-value add. And well, the value adding is about cost time, cost money, and add value. This is valuable things. And non-value, it's about effort, obvious ways, and here, of course, cost time, cost money, and adds no value. This is about waste. Well, the next topic is quality in the TPS. Producing high quality products is paramount for any manufacturing industry and therefore must be a priority. The cost reduction versus cost plus. Here in the Toyota production system secures profits through the principle of cost reduction. And with the principle of cost reduction, the sales price of a product is determined by the customer and market. In addition, our customers are demanding yearly price reduction in order to maintain margins and profits. We must continuously eliminating waste and reduce cost. The productivity. Here we have the formula in the screen and its productivity formula. Outputs under inputs. So we understand that all that we have in the warehouse, the inventory, and the production needs to be needs to be lower than all that it's outside. I mean, the inventory needs to keep a balance. So improvements in efficiency that ignores the production schedule or customer demand will result in the waste of overproduction, as I said before, and push overall company inefficiency in the wrong direction. Total efficiency is when considering how to raise a company efficiency by elimination of waste. We must look at efficiency in terms of each process, the line embracing those processes, and the whole plan that contains the line. The next one are the total efficiency framework. Managers and supervisors in this case tend to think of improvement in efficiency and quality only for their own process, but they must always consider how local improvements will affect total operations. Well, this means that managers need to focus more on the local areas that they are able to manage, like management system, industrial symbols, symbiosis, or maybe efficiency assessment. These include many things like waste production, material energy, people engagement, improvement strategy, simulation, and decision support. The next one is safety and moral. And in the Toyota culture, it is impossible to achieve significant quality, cost, and productivity improvements without consideration for safety and moral, of course. Issues that affect individuals are critical, important, and must be addressed continuously. Let's talk about safety. This is about improving workplace safety and ongoing topic for continuous improvement. This reducing workplace hazard shows respect for people and moral. It's that all Toyota employees are expected to contribute to a creative positive workplace. So, since much of our personal identify is a reflection of work experience, pride, and integrity.
Hi, my name is Daniela Alicia Ramirez Sandoval, and I'm going to talk about just-in-time, Hidoka, and Kanban. Let's start with just-in-time. The just-in-time can be defined with a single sentence. Do only what is needed, when needed, and in the necessary amount. Phases for the implementation of just-in-time. The first phase is how to get the system up and running. The just-in-time application requires a change in the attitude of the company, and this first phase will be decisive to achieve it. To do this, it will be necessary to take the following steps: basic understanding, cost-benefit analysis, commitment, decision yes, no to implement the just-in-time, selection of the project team for the just-in-time, and the last one is identification of the pilot plan. The second phase is mentalization. The program should be structured in such a way that employees begin to apply the just-in-time philosophy in their own work. The third phase is called process improvement. The aim of the first two phases is to provide the right environment for successful implementation of the just-in-time. The third phase refers to physical changes in the manufacturing process that will improve the workflow. The fourth phase is improvement in control. How the manufacturing system is controlled will determine the overall results of the just-in-time application, which are as follows: track-type system, local control instead of centralized, statical control of the process, and quality at the source. That it means self-control, suggestion programs, etc. The fifth phase is customer-supplier relationship. In order to continue the improvement process, you must integrate external suppliers and external customers. The fifth phase should start in parallel with part of phase 2, 3, and 4, since need time to discuss just-in-time requirements with suppliers and customers and changes to do, take time. The second process is Hidoka, that it means build in quality. And Hidoka simply refers to the ability of humans or machines to detect an abnormal condition in materials, machines, or metals, and to prevent the abnormality from being passed of the next process. The objectives of the process control and the station are to 1. Increase quality by preventing mass production of defective products. Number 2, avoid injury to employees or damage to tools. And number 3, separate human work from machine work. Guarantee the quality of all products. That it's part of Hidoka. An inspector inspects parts and finishes the products before delivering them to customers. However, parts cannot be guaranteed without defects if inspectors examine finished products. And building on quality, add quality to the process. This principle gives team members the responsibility to check quality thoroughly at every stage of their work so that defects are not passed down. Each team member should be aware that the downstream process is a customer and should never deliver the defective product. The next one is building quality in each process. In practice, improving quality in each process brings the role of the inspector in each process so that defects can be discovered immediately. If defects are discovered in later process, it's not good to simply correct them, because if the root cause is not investigated and eliminated, the defect will continue to occur. And the next one is inspection work. Judge if finished parts or products are good or bad is not enough. They should also look for the cause of defects, institute measures to effectively prevent their recurrence. The next one is injury and damage prevention. By stopping production as soon as a problem occurs, we can protect employees, prevent damage to equipment and tools. The first thing to do when production stops is to get it back up and running. As long as there is not threat to the safety of team members, of the quality of the parts. Standardization is one important. It consists of methods to limit variation in the process and achieve efficient production and a timeline manner. Another process is Kanban. Kanban is generally recognized as a card that passes between processes communicating information about what materials to replenish. You can say that there are two main categories. That it's predetermined Kanban, a license to take from a store an area of the central market, or instruction, that it's the second, instruction or signal Kanban, a license to manufacture a product such as telling a molding machine to run a certain quantity of product B. The steps to follow for the implementation of Kanban in our company. It's first, visualize your workflow. That says design your workflow. Take a series of steps to get product drawing on the board. Draw it on the board. The second is establish the limits of your work in progress, of WIP, work in progress. For example, the first one, it could be call customers, acquire lead, or close deal. And now the second is establish the limits that evaluate the limits your team has of performing tasks. The third is flow management, that consistently review how it works. And improvements. The rules of the game, that establish rules for performing the work. This must be agreed with both the team and the organization. And the last one, improvements. We can use many methods, self-examination, see the failures of the equipment and the process, and so know that we must improve.
Hi, my name is Stephanie Ruiz Urbina, and I'm going to talk about takt time. The labeling of the production quantity means that one product should be manufactured in a given number of minutes and seconds. This time is called the takt time. This is based on average quantity required by the customer. Takt time is calculated using the following information: time available for manufacturing for the same period of time and customer requirements for a period of time. I'm going to introduce an example for a better understand. An assemble area must make 2,500 units of product A and 70,500 units of product B in a month. The area work is scheduled for 2 8-hour shifts and has a morning break of 10 minutes, lunch break of 20 minutes, and afternoon break of 10 minutes. The first step in calculating takt time is establish customer requirements for a single shift. The customer requires a total of 20,000 units for the month if there are 20 workdays in the month. The customer requirement per shift is 20,000 units divided in 20 days divided in 2 shifts. This is an equal of 500 units per shift. The second step is to determine the time. This is usually in seconds per shift available for manufacturing products. Well, the shift is scheduled for 8 hours or 480 minutes. We will subtract 20 minutes for breaks and 20 minutes for lunch. The time available is 480 minutes less 20 minutes. This is for breaks, less 20 minutes. This is for lunch. This is an equal of 440 minutes or 25,400 seconds. Once customer requirements and time available have been figured out for one shift, then we calculate takt time. Well, this is the way to calculate takt time. This is time available divided in customer requirements. If we substitute the data, this is 25 400 C per shift divided in 500 units per shift. This is a total of 52.8 seconds. Well, now I'm going to talk about continuous flow processing. Eliminating the congestion of parts within a process or between processes and achieving sequential flow production is called continuous flow processing. This is the most usual in the system Toyota productions. The continuous flow process involves moving one work unit at a time between each step of the process, with no breaks in time, sequence, substance, or extent. For most applications, continuous flow saves time, energy, and cost, and when implemented correctly, it can reduce waste, save money by reducing inventory and transportation costs, increase productivity by completing more units in less time, improve quality making it easier to spot and correct errors, cut down on overhead via increased stability and reduce lead times, adapt to customer needs more effectively than batch processing. Well, now we are going to talk about batch processing. Batch processing involves the processing of bulk material in groups through each step of the process. Processing of subsequent batches must wait until the current is finished. Perhaps the most defined advantage of batch production is the lower initial setup cost. It's considered easier and cheaper to implement a holistic system of batch processing equipment, although this is not always true. Batch processing also allows you to set up process uniquely to adapt to the materials you are working with. If you foundry, mining operation, or bulk processing facility needs to differentiate the flow for each batch, they may be ideal. Well, continuous flow versus batch processing, as we um, can see, involves, well, continuous flow involves, as we said, moving one work on the unit at a time between each step of the process. In this example, we have the process of the pizza. We finish one to start with another one. And in the batch process, this involves groups of pizza. This is the difference. Well, now, continuous flow requirements. The following measures are necessary for continuous flow processing. Products is the first one. Consecutive production, manufacture and assemble each single piece or unit in the process order, so the products will flow one after the other between team members and processes. Small lots shorten the die change machine setup time in lot production process and keep the lot size small. Now we're going to talk about the other two things that are super important for the Toyota production. Employees. Multiple processes responsibility, multi-process handling. Arrange a system so team members perform several tasks that match the task time according to the work sequence. 2. Multiple skills team members, multi-skilled team members is called. Always provide work training to the team members so that they can operate various types of equipment, do various kind of work, and perform other work besides that for which they are directly. And now equipment. The equipment is the process sequence layout the equipment in the order of process, so sequential production and multi-process handling can be done. 2. Equipment with simple setup after the system to eliminate adjusting work or changing of associated equipment in order to shorten the setup time. It requires great effort in the lot production processes to keep the lots small and to create a production flow. Well, now we have the equipment reliability. Is critical to a Toyota production system. There are 4 critical factors to consider when addressing manufacturing equipment. The first one is uptime. If every process can obtain the necessary parts at the required time just in time and in the proper quantities, there will be no need to maintain stocks of extra materials of parts. However, what are the appropriate countermeasures if equipment breaks down and the operational rate is lowered, with an accompanying decline in production or if defects in quality occur frequently? Well, the second is changeover. The changeover capability of equipment is important for continued flexibility, production smoothing, and capital savings. The ability to change over and set up equipment quickly and accurately will go a long way in eliminating the wastes of waiting, overproduction, and inventory. By maximizing the time equipment can be utilized, making quality parts. we minimize the need for additional equipment. This is world-class injection molding changeovers take less than 180 seconds. And the third is quality. Molding machines, robots, and other equipment requiring setup need to have standard settings that can be executed by the operator of documented. Standardize all settings so that the equipment can produce a good part the first time. We must stop adjusting things. Improvement efforts can determine that a new setting is in order. This new standard must then be documented and implemented. These standards are critical for consistent quality production for manufacturing equipment. And the fourth is procurement. When purchasing new equipment, we must consider buying the minimum capable of meeting our requirements. Reliability and ease of maintenance should be considered before features. Best and wish lists can often be added later if the needs arises. We want to avoid buying features just in case. We must consider uptime, utilization, and quality factors when making equipment choices.
Minimize stock. Reducing the size of the stock also requires a very good relationship with suppliers and subcontractors, and thus helps to greatly reduce logistic cost of ordering, storage, and maintenance. Zero tolerance to errors. Nothing should be manufactured without the security of being able to do it without defects, since defects have a significant cost and also with defects there are late deliveries, and therefore the sense of the GIT philosophy is lost.
And the 5S methodology aims to create more organized, orderly, clean, and safe workplace through its knowledge and application. It is intended to create a business culture that facilitates, on the one hand, the management of the company's resource, and on the other hand, the organization of different rural environments with the aim of generating a chain of behaviors that impact on an increase in productivity. It has a direct impact on the way works do their jobs. They represent basic Japanese principles whose names begin with the letter S, and Seiri, Seiton, Seisu, Seiketsu, Shitsuke, and classify, order, cleaning, standardize, and discipline.
Well, let's talk about the total productive maintenance or TPM. Well, this is all about perfect production. I mean, no breakdowns, no small stops or slow running, also no defects. It value a safe working environment and of course, no accidents. Well, here the TPM emphasizes proactive and preventive maintenance to maximize the operational efficiency of equipment. Well, we have to keep in mind that if we empower our operators, and they will help us to maintain the equipment. The traditional TPM has 8 different pillars, and well, these are autonomous maintenance, plan maintenance, quality integration, focuses improvement, also early equipment management, training and education, safety, health, environment, and the last one, TPM in administration. We will talk of each one in the next slides. And also the traditional approach to TPM was developed in the 1960s and consists of 5S as a foundation and 8 supporting activities, sometimes refers to as pillars, okay? So the 8 pillars. So these are mostly focuses on proactive and preventive techniques for improvement, equipment, reliability. So the first pillar is autonomy, autonomous maintenance, that it's all about give responsibility to the operator that is working on the machine. Also, well, the second one is planet maintains, that this it's all about schedule. The next one is quality maintains, and this designs error detection and prevention into production process. Well, here it's like eliminate recurring resources of quality and also defects. The next one is focused improvement, and well, needs to have small groups of employees that work together proactively to achieve regular incremental and also improvements to equipment operation. The next one is early equipment management. Then these are that the directs practical knowledge and understanding of manufacturing equipment gained through TPM towards improvement design. The last ones are about training and education, that it's field in knowledge, safety, health, environment. This is all about maintain and safe and healthy working environment. And the last one, TPM in administration, it's of course apply all the operational knowledge that we already have about these 8 pillars in administration functions.
The second part that I'm going to talk about is quality in the source zero defects and provider networks. The quality in the source zero defects, the goal is to achieve zero defects, for which it is necessary to identify quality problems at the source, also called ROCs, solve them, and never let a defective product pass. Supplier networks or provider networks need to meet stringent quality requirements and be located in the vicinity of the company to facilitate frequent deliveries or small batches of the part or components. And that's all.
Now I'm going to talk about Kaizen. That means continuous improvement. This is a strategy where employees at all the levels of a company work together proactively to achieve regular and incremental improvements to the manufacturing process. In a sense, it combines the collective talents within a company to create powerful engine for improvement. This is a strategy very useful for the Toyota company, but also for all the companies around the world that wants to improve their efficiency. A typical Kaizen event goes something like this. Set goals and provide any necessary background. Review the current state and develop a plan for improvements. Implement improvements. Review and fix what doesn't work, and report results and determine any follow-up items. Well, this type of circle is frequently referred to as PDCA. Well, what does it mean? The P means plan. In this case, analyze current problem and conditions about the company, establish change objectives, and create processes to achieve solutions. The D means do. Implement the plan test small changes, and gather data on the changes' effectiveness. Then the C. The C means check. In this case, evaluate data and identify deviations between outcomes and planned objectives. And finally, the letter A. A means act. Standardize the solution and review and define next issues. Well, now these are the advantages for the Toyota production system. The first one is reduce cost. Reduce cost is when time savings in the production process because the just-in-time strategy makes better use to the company resources. Sorry. Then we have look for efficiency. What does it mean? Well, these avoid unnecessary movements and environmental conditions that impede work efficiency. Then we have optimization of the use of technologies. This means that we optimize the use of the technologies in the company and reduce waste. This is to minimize all form of waste. This includes everything from material defects to worker ergonomics. Finally, the products satisfy the needs of the customer. The products satisfy the needs of the customer since they are not only quickly understood, they are also quickly introduced into the production process. And now the disadvantages. It is necessary to assess improvements. Why? Because tracking productivity and waste can affect the time used for production. The value of the improvements should be examined. If the performance in a section managed to be greater than that of a previous stage, the results have not been improved. And other disadvantage is that works better with stable components. It works better with stable components. Any restriction not accounted for in planning potentially puts the entire system at risk. And there are not unique pieces. There is no such thing as unique pieces. The individuality and originality of the product is lost. That is what it means. And finally, the last disadvantage is that sometimes planning ahead is more difficult depending on changes in the market. Planning ahead can be difficult due to changes in the market.